there needs to be a conversation about how spray foam changes the way buildings work. Hi, I'm Robert Naini, your spray foam advisor and the guy in the Hawaiian shirt. I wear the Hawaiian shirt as a symbol of freedom and flexibility, something that all business owners should want to achieve. You know how most SPF contractors start their business because of their technical skills, but they have no plan for growth? There's no consistency because decisions in their business are made on the fly. They are just trying to get through the day. And they are spread too thin because they do everything themselves. Well, what I do is help SPF contractors like that measure profitability, identify the key activities that drive success in their business, and create a game plan that develops consistency and growth. Let's get into it. Today, I want to talk about builders. Specifically, when you start talking to a new builder or prospective client, someone that doesn't work with you, someone that doesn't use spray foam, there needs to be a conversation about how spray foam changes the way buildings work. If they have already started the process, if the building is already designed using fiberglass or cellulose insulation, what needs to be reviewed to make the transition to spray foam? This is a really great question to consider as you are talking to builders, because you're going to come across builders who have already started their designs and the planning stages, and their structures currently are under construction using other materials. These buildings already have HVAC calculations done based on traditional building envelopes. And when you introduce spray foam to that structure, you are fundamentally changing the way the building works, right? You are changing the thermal dynamics from an insulation perspective, the airflow dynamics, and possibly the vapor retarder characteristics of the building. This is going to impact the heat flow, the moisture flow, and the overall temperature dynamics of the structure. So the manual J calculations for these structures, the sizing and design of their mechanical systems, should be verified based on the new building envelope. The manual J calculation takes into account a lot of different components: the orientation of the building, the percentage of area that is windows, also called glazing, the amount of duct leakage, where the ducts are located, and natural air changes per hour. All these variables are incorporated into manual J calculations, and the HVAC contractor or mechanical engineer has to process this data appropriately. What they really need to know is that when spray foam is introduced into a building enclosure to create an unvented attic, the air tightness goes down, the structure gets tighter, and there is less air leakage. This should be reflected in the manual J calculation. The duct leakage is reduced to zero because the ducts are inside conditioned space and the duct losses are maintained inside the building envelope. This should also be reflected in the calculation. When these benefits come together, the size of the mechanical system is typically smaller when using spray foam compared to a traditional design using fiberglass or cellulose insulation. If you found this video helpful, then it would probably be valuable to your friends in the spray foam industry. So help us all out and send it to 3 or 4 people that you know. Additionally, if you have any questions, want info on a specific topic, or want to learn how Spray Foam Advisor might be able to help you or your business, you can email us at questions@sprayfoamadvisor.com. This has been Robert Naini, your Spray Foam Advisor and the guy in the Hawaiian shirt. Thanks for checking this out, and catch me on some more videos.